So the next question is the Fourier transform of the given function f of x equal to 1 by x square plus 2. So the given Fourier transform dx, instead of f of x we are going to substitute the given value dot e to the power I kx. So we have to do the simplification of the function because we are going to use the contour integral for this real integral. So first we can do the simplifications. That will give dx 1 divided by z square plus 2 e to the power I k z. So if you are seeing this pole of the function, pole means where the function is diverge, means when the denominator of the function goes to 0 then it will diverge. Those points are poles in the complex plane. So the poles are exist at z square plus 2. If the denominator goes to 0 then it will diverge. So the given function is not analytic at the particular points. Those points are called poles. So z square equal to minus 2, so z equal to plus or minus I square root of 2. So if you are drawing the complex contour, this is the real axis x, this is the imaginary axis iy. Your poles exactly lying in the imaginary axis. So take your contour from here to here and then rotate in the clockwise direction and then finish it. So there is one known pole. We know that according to Cauchy-Riemann integral formula, the integral any closed contour of f of z dot ds should be equal to 2 pi I sum of the residues inside the contour. So the closed contour integral will go, we can take this limit is minus infinity, this limit is plus infinity, the radius is bigger or the radius bigger or always goes to infinity around the complex plane. So the integral first part goes from minus infinity plus infinity on the real axis. So you can write it as, already we know the function is this early. So along the real line minus infinity plus infinity dx, here it is not dz because it's a real axis, so dx 1 divided by x square plus 2 e to the power I kx, everything is real, plus the second part is curved path. This is a curved path, so the first integral then second integral then it is closed. Curved path is in the complex plane, so you can written as dz 1 divided by r square plus 2, sorry, z square, the complex plane you can written as z square e to the power I k z is equal to 2 pi I sum of the residues. So there are only one pole inside the contour, so you can return the given function 1 divided by as a factors. So z minus I square root of 2 z plus I square root of 2 e to the power I k z, because we want the residue value, we want to throw away the point which one is blows up this functions. So which point will blows up means it will blows up this point, so we can throw away that point z minus I square root of 2, then we will find the residue value of this. We can throw away, we can find the residue values. So integral minus infinity to plus infinity dx 100 by x square plus 2 e to the power ikx plus z here is r e to the power I theta. You can call it as theta. This z, so z is equal to r e to the power I theta. As r goes to infinity, the radius goes to infinity, then denominator will blow. So radius goes, sorry, not denominator will blow, denominator will blow. So 1 by the infinity, it will goes to 0. The curved integral goes to 0. So 2 pi I, we can cancel these two. So we are evaluating residue value at z equal to I square root of 2. Just we are removing that point. By removing that point, so it will give e to the power I k z value is I square root of 2 divided by 2I square root of 2. I think I'm right. Yes, 2I square root of 2. If you are substituting here I square root of I square root of 2I square root of 2. So the final answer is minus infinity plus infinity dx e to the power ikx divided by x square plus 2 is equal to, you can cancel 2I, 5 by square root of 2 e to the power I into I square minus k square root of 2. So in the question, the given option is 3. Option is 3.